Okay, am I audible? Shubham, am I audible?
Yes, sir.
Okay, thank you. Okay, fine. So please let me know whether my screen is visible you all or not. Is it visible?
Sir.
Okay, fine. So very good morning to one and all. It is our last lecture, I think, regarding syllabus coverage. Okay, so already we have gone through the all our 5 unit, and this is the last topic of our 6th unit, and that is all about the uh, just a minute. Okay, fine. So whatever we are going to deal now, that is about the grounding of impulse testing in a laboratories. Okay, so important thing is that whenever we are talking about the design and planning of the laboratories, at that moment the first and foremost important thing is that how we are going to earthing that, or we are going to grounding that. Okay, so in such condition, what we are going to do is that what kind of grounding is there, what are the basic types of the grounding that we will understand. Okay, so before understanding that one, we should revise whatever we had understood is that test facilities whatever provided in a high voltage laboratory, then what kind of activities as well as the studies that can be carried out into the high voltage laboratory, as well as whatever be the classification of the high voltage laboratory, as well as sizing and rating of the high voltage laboratory we had understood last lecture, right? So now we will move towards the our next point, that is and last point, grounding of a impulse testing laboratories. Okay, so in this case whatever be the earth, or we can say the grounding system is there, that system we need to establish. Why? Because as we know that there is a higher potential which will be occur whenever there is some kind of overload, some kind of over voltage, or some kind of fault is there. That time we understand that there is a high potential that will grow now. So whatever that high potential is, that we have to give the reference for that, and that time whatever be the reference potential we are taking, that has to be that has to be delivered to the zero potential. Means suppose this is my laboratory, and in that laboratory suppose somehow there is a equipments like that way, equipments. So whatever be the earthing that I am doing here, that earthing. Okay, so there will be this is a earth pit, and in that I'll provide the earthing. So whenever there may be a kind of hazard like that way, whatever be the excessive amount, that will directly goes to the zero potential, that means it will ground. Okay, so whenever it is a grounding, at that time whatever be the excessive potential, that will reach to the ground. So what are the various types of the grounding? Then there is a three types basically. So first, that of ideal ground, then second one, that is the single point ground, and the third one, that is the burst ground. Okay, so that three grounds we will understand one by one, and whenever we will understand that three grounds one by one, at that moment you should just keep in your mind that this grounding will comes into your pictures whenever you will work at any industry as a maintenance engineer, as a installation engineer. At that time this grounding or earthing is very important. So The best ground is nothing but what ideal ground. So means that is actually in a practical life or a practical schedule, this is not a realized one. So after this ideal, second one is a single ground, and the last one is a bus ground. So that is again a little bit satisfactory, I can say. So in ideal ground, what will happen? So in ideal ground, we will just provide some finite conducting materials, and that material that will have some of the copper sheets or some of the welding units, we can say, and that has to be which are now you are thinking about the copper for the earthing, then that will be have a little bit maximum cost. Okay, so commonly we can say that ideal, which is having the copper metal that is welding to the single unit and it is given to the earth. Okay, so basically, if we will talk about the normal or ordinary things, then the single point grounding is mostly preferred. So in such kind of single winding, we can say whatever be the earthing grid that will be installed, so that is again within its laboratory floor area, and that whatever be connections from this grid we are taking out, that is given to the single point of the copper conductor. So that is why there is a common ground point. So if we will talk about like that way, so if suppose this is my building, so whatever the in this building there are equipment flow, all these things, so what I'll do, I'll just take whatever be the points of that common to the one thing, and that will goes to the earth. Okay, that will be goes to the pit. So like that way, it may come into the pictures. Okay, so very important thing is that whenever we will think about the whatever be the single point, as well as whatever be the large size copper conductor that we are going to utilize, that is again a costlier thing, and we should have to take care of that one also. Okay, so now we'll take you to the next. In that case, yeah, fine. So in such cases, again, we'll think about the whatever be the ground connections we are talking about. That ground connections again a very important role playing in case of these when we can say in case of these various equipments are whatever be the used that are for the uh, high voltage test. So it is a most, or it is a simply thing that it should have a very useful the common ground. And if suppose it is having a common ground, that time suppose we are planning to take a high voltage impulse test, and during that impulse test, whatever be the high current that will be into several kilo amperes, so that will be suddenly goes to the ground, and that should be around 10 raised to 7 to 10 ampere per seconds. And if suppose we will not take a proper care, or if suppose will not focus, or will not uh, if suppose will not concentrate on such kind of care, such kind of damages will be happen, and that may be risky for the people which are working there over, and it is also playing with the people's lives. Okay, so if in suppose we thinking about to avoid such kind of things, so there will be a copper strips that are used instead of these conductors. So see, the conductor is a I can say that will be like that way conductors. And if suppose I'll talk about the uh, copper strip, so it may be like a strip like this cell phone, so that may be a strippers. Okay, the difference between strip and the round conductor. So to avoid such kind of the implications, there will be a strip conductors, and there is whatever be the inductance which is lying into this conductor, that may get reduced due to these strip conductors whatever we are using. Second thing, that whatever be the metal grid that are available on a concrete floor, so it will have a means it will there may be a little increase in resistance as well as inductance, whatever be the ground circuitry will be available then. And the important thing, that is ground whenever it is only effective when there is a large size trees whatever the used for the closed spacing. Means whenever there is a very smaller or closed spacing which is around less than 1 or 1.5 meters, And then we can say there should be a larger size copper strip should be used, and then and only then it will become effective. So whenever we are thinking about this ground system, then some conditions need to be followed, and we have to ensure that conditions. So in that case, first condition will be that imperfection of a grounding system are to be avoided. Means what? Means if suppose we are doing a grounding system, or we are planning to install a grounding system, that time it should be perfectly installed. There should not be a single case which should be imperfect, right? So if there is any single thing that is we kept an imperfect, at that time we can observe, or we can experience some cause of the excessive voltage difference between the some of the points, or it may cause some flashovers, there may be a damages, there may be a dangers to the human life. So such kind of things we need to face if suppose we'll not take care about the whatever be the grounding system we are implementing. Then a grounding system that should be such that the voltage drop along the ground system and the voltage at a loop and the circulating currents in the loop are avoided or minimized. Then again, very important thing, if suppose here I'll show you with the figure, if suppose my fault is these are the equipments. Okay, these are the equipments. Just hold on. Hello. Okay, fine. So if suppose this is a one laboratory and there is equipment, and suppose there is a hazard, okay, there is a hazard or there is a problem that is occurred, so it is not necessary, or it is it has to be avoided that this whatever excessive current that should flow through these devices, that current should be directly goes to the earth without wasting a time, without circulating, without flowing into the loops. That should be avoided, and the current should directly goes to the earth. So that should be that care should be taken out. That is more important. Then last, then third, that is fourth condition, that is the metal conduits, whatever be the, I think the second point we have missed, that imperfection will cause excessive loop currents along with the sheath of measuring cables, which will introduce errors in measurement. Now I'll show you the one example. If suppose we want to take an experiment at our home, whenever we will keep that wires as a binding like that way, means if suppose some kind of wires, and that we will keep like that way, if like that way we will keep the wires, you can see here, if I'll keep wires like that way, then there is a major we can say like that way. See, if suppose wires are kept like that way, means bunch of wires, that time what will happen, that every wire is carrying a current, and due to that there whatever be sheeting is there, that may get damaged, there may be a some temperatures, and due to that there may be a causes or errors into the measurement. So that care also we need to take care. Then again, another thing, that metal conduit should be used for the measuring and control cables. Uh, Avoid neutral inductance effects between the ground grid and the cables. Means what? Means whatever be the conduits are there. Means whatever conduits means a whatever copper strips we are thinking about, whatever be the copper round conductors that we are taking into the picture, that should be having a controllable cables, and there we will avoid whatever be the neutral inductance will be there. Why? Because if there is a neutral inductance, then that may be a getting a breakdown of these cable wires, or that whatever be sheathing or armoring that has been provided, that may get heated, or due to that if their insulation may get failure, and then maybe a short circuit may happen. So for that purpose, whatever be the metal conducts that we are using, that should have a proper control, as well as that should have a proper measuring devices which are to be connected. Okay, so let us move towards the figures. So here you can see there is a laboratory hall, and there are two different laboratory halls I have shown here. So first, that is about the single point, and the second is about the bus grounding. So in first, here you can see this I is nothing but what? This is a IVG. This is IVG. Okay. Then the number two, that is a spare gap. That is a spare gap. Okay. I'll write a short forms. Then 3, that is the position of test object. So this is the test object. Okay, this is the test object. Number 4, that is the ICG. That is the ICG, means impulse current. Sorry. Means ICG means what? That is the impulse current generator. So I'll write here ICG. Okay. Number 5, again, that is the test object for the current measurement. Right. Then number 6, that is a control room. Okay, here is my control room where 1 or 2 persons will monitor, as well as they can observe, they can keep an eye on a all other equipments, how it is performing, or it can see, he can see the parameters. So then number 7 that we have here, that is a rectifier, charging rectifier, we can say charging rectifier set. Then E, here you can say this is the earth position, that is the earth. I will write simply earth. And then G, here you can see we need to give the ground connections. So 1 2 3 4 5 6 already we had given, and in another figure here you can see the particular separate G. Okay, there are various G stands for the ground connection and GB stands for the ground bus. Okay, so now again, the simple first single point grounding means what? All other equipments are connected to one point, and what happens if suppose there is a problem, there is a damage in a charging rectifier, then high current directly goes to the charging earth. If suppose there is a problem in a ICG number 4, then the sudden current will goes to the earth. Means that single point grounding is very important. It is usually that has to be used. Okay, so this single point grounding, again I'll repeating that winding which having a single point of earthing and all other equipments are connected in a laboratory. But in case of the bus grounding system, there we can see whatever be the laboratory hall is there, there may be a grounding bus, so separate grounding are providing. So for this, there is a separate, for 1 and 3, there is a separate grounding. Then there is again separate grounding for 2, there is a separate grounding for the 6, separate grounding for the 5, 4. Means if suppose any of the, now see, in what in case of the single point winding, what will happen? Sometimes what will happen, this current may goes to this side also, this side also, if their potential is lower than this. So due to that, in single point winding or single point grounding system, there may be a chances to circulate or to flow the current into loop. But in case of the laboratory hall with the bus grounding system, in that such conditions, whatever be the current, whatever be voltage that is going beyond the limit, that directly goes to the ground system, because but every particular system, every particular point that is having its separate bus grounding system. So that is the importance of the we can say grounding system. So I hope you have understood that very well. Then next point, that is in case of the earthing system, as we know that there is a around 1 meter wire should be there, or 1 meter copper network should be there, and that should be let down below the ground level. So and that time we can go for the impulse test, as well as whatever be the hold on a second. Yeah, so whatever be the grounding system that we are thinking or planning about, that should be have a some of the some of kind, or we can think about the yeah. So in such cases we will think about like that way, whatever be the planning that we are going to do, whatever be the things that for the impulse test, so that time their area should be provided with the spread, or there is stretching, or there may be a copper grid on the floor of the thickness of ground rods around 2 millimeters. So there should be a means all these specific conditions as per the Indian standards or Indian electricity specifications, we can say. So whatever be the rod that are welded, that should be inside the copper grid, as well as the whatever surface of copper grid that has provided, that should be welded with them. So whatever be earth connection we are providing, and that should be for the every 16 square meter area. Means what? Means for every 16 square meter area, there should be a shortest lead that has to be used, and it should be connected to the laboratory. Now you will say, you will ask me, sir, in our laboratory, in machine laboratory, which kind of winding, which kind of grounding system is there? So I will say there is a bus grounding. Means what? inside the laboratory there is a separate grounding system, and then all this taken out to the outside. So you can see whenever you will visit to the campus at that time, behind the machine to lab there is one earthing. So you can if once you will visit, then at that time I will show you. And this is a copper strip. This is a copper strip. Why? Because the reason behind using the copper strip is that it will have a less neutral inductance effect, and due to that we prefer to use the copper strip winding. So when whatever be the ionization measurements we have to be taking at that time, whatever earthing that we are considering at that time, its RIV levels, mean whatever be the radio interference voltage or radioactive, whatever be the voltage level, that should be the lowest to the external sources, or we can say it should be having a low value. Okay. So in such cases, or we can say in addition that whatever be high frequency energy produced during the impulse stage, that not cause any whatever the damages to the testing area. And if suppose such all the conditions or criteria will meet to the entire laboratory, then we can say that laboratory is nothing but what Faraday's cage. Okay, means what it will be the useful for the all other applications or measurements or generations. Now another one more important point, and the last point we are taking here, that is electromagnetic shielding and earth return in a high voltage laboratories. So friends, important thing that electromagnetic shielding and the earth return. So whatever be the high voltage laboratories, in cases of the sizing that should be a small, medium or large, that have some type of a screening against the electrostatic as well as electromagnetic field interferences. So that screening is important, and it is a possible only and only when there is a partial discharge measurement are to be in a laboratory. So in such cases, whatever be the attenuation, as we know that there is a amplification as well as some like that, there is attenuation which should be less than a bandwidth or frequency of around 14 dB. So why? Because whatever be the attenuation of electrical signal in the frequency range, that is a 1 megahertz. So while whatever be the lower attenuation is needed, that should be for the electromagnetic signals only, and that we have to take care whatever be the screening that has to be tuned for the pocket radios or some walking, like you are people taking your mobile phones in a college and in laboratory. That time whatever be the frequency ranges that are between the 5 kilohertz to the 100 megahertz, and at that time whatever be the signal will be there, that should not be heard. So in such cases, it is possible that whatever the automatic volume control, means we can say there is a gain control, and if suppose that signal is not listening, at that time it is disconnecting. So whatever be the disturbances sources are there that are in laboratory is like switching transient due to the switching off or switching on the loads, transformers, then rectifier circuits, then whatever the shielding cables which are acting as antennas, and such kind of cases there may be a outside signals which can pass into the laboratories, and at that time you may see there may be a radio interference. So avoid that, we need to take a electromagnetic sheathing as well as earth returning process into the high voltage laboratory. So what kind of care should be taken? So best care should be taken, that is, if whatever our roof or whatever rule walls and whatever flooring area is there, that should be screened first with the expandable metal wire as well as whatever be the mesh wire that has to be joined together, and all the electrical equipments which should be fully screened with the metal conduct. And whenever there may be a case of the measurement, at that time every time we should take care that one point in a laced circuit, that should be have a test object, and that should be have a reference to the ground. So due to that, if suppose there in kind of the damage that should be recently goes to the ground, and whatever be the disturbances will occurrence into the measurement, that will not occur. So like that way, there may be some kind of spikes, and we can say there is a control room where we are going to take a testing of the impulse points or impulse circuits, and it should have some operating signals where we will see there will be a large magnitude to the control impulse generator. So whatever be the potential difference that is generating in between the earth and in between the whatever your test objective, that should be a goes to the ground, or which we will say that should be raised to the zero potential as early as possible. And if suppose that things are possible, then your impedance will get reduced and it will become a ground standard test circuit. And such cases, what will be the most important thing, that most important thing we have to understand, that is whatever be the return conductor are there, that return conductor in form of such kind of metal strips or some kind of some copper strips at that time, which are placed top of the floor. So due to that, if suppose, as we know that the whatever be the pressure, so top to low, that pressures will flow some kind of like that way. We have taken consideration of these floor area, which whatever be the conductor returns has been connected. And some of the laboratories which having a copper nets as well as some aluminum nets, or we can say some of aluminum sheets. So in such cases, what we can say, that electromagnetic shielding as well as earth return in a high voltage laboratory will takes place. So this is all about the unit number 6, and very important, that high voltage laboratory design and planning. Okay, so if you have any questions, please you can ask. Otherwise, we'll go for the some thrilling, we can say, virtual lab experience. Okay, so is there any questions? Yes, Saurabh, Arbaz, Shivaji, any questions? Vaishnavi? I'm asking to, am I audible? Okay, Saurabh. Okay, fine. So I'm stopping PPT presentation, and now we'll move towards the, okay. Okay, by today evening, I will share assignment questions, as well as I'll share, already I had shared you MCQ questions and MCQ objectives. So, and already I had shared a one or two books, right? Which are about the CL Vadva, and another one was about the V Kamaraju, right? So whatever concepts we have taken here, that are up to in this, whatever notes I am preparing, in that also same contents are there. So again, I will share PPTs also with you all by today afternoon. So whatever write-ups I had given to you, you can write it down by using the PPTs with the help of these books. Okay, and notes I'll share recent. Okay, so now we'll go to the next point, that should be about virtual lab. Okay, so I hope, now let me share screen again. Okay, please ensure whether it is visible. Is it visible? Am I audible or not? Okay, yes.
Yes, sir.
Okay, fine. So let us go for the electrical engineering. Let us go for virtual high voltage. And here is the list of experiments for you. So now let us, already we have seen the impulse voltage generator. Now let us go for the impulse current generator. Okay. So for the impulse current generator, you can see here on your screen the impulse current generation of the impulse current high magnitude, that is 100 kiloampere. All that things are given. Then you can go for the theory. So all other theories, whatever we had understood, see here the rising current is maximum, the rising speed is very less, and the whatever it is another slope that we had said, tail time. So here it is a front time, this is a tail time. So tail time is again maximum. So you can see here tail time is around 20 to 80 microseconds, where front time is around 1 to 30 microseconds. So like that way we will go for the third theory. Then what are the objectives? So exponential impulse current test for verification of current rating, and another that is residual voltage like a surge arrestor. So I'll click on the simulator here. So you can see the ICG simulator on the next tab. I'll open here procedure. So now we will read one by one procedure, and then we'll move towards the move for the whatever be the current generator here available. Okay, So now here you can see on in front of your screen, this is a 3D diagram. Okay, so you can easily have a look on it. Okay, so this is a 3D diagram. There is a capacitor bank, there is a transformers, all the things has been given. So this is you can easily whenever if you're having a laptop, then at your home also you can easily have a look on it. Okay, so this is all about the okay, so let us start to fine. So this is all about our whatever with ICG is there. So first thing that we will check whatever you can see like that way. Then now what I will do, you can see careful. So here the first thing, whatever the values are given, I'll keep as it is. Whatever capacitors value, whatever the charging value that has given, that I will keep as it is. Okay, I'm not going to change any value. But whatever be the values for these default values that has given, so I'll keep as it is, and whatever be the what LF or L1, that values also I'm not going to change. So I'll click on the start experiment, so you just have a focus on it. I'll click on the start experiment, so experiment is started. Then I'll click on the ground switch. Now you can see where is a ground switch. So you will come to know there is a ground switch. Okay, there is a ground switch. So I'll again click on the restart. Okay, let me refresh the page. Now see this white color switches is there, that is a ground switches. Okay, okay, someone please unmute and tell me whether I'm telling you are getting or not. Someone just unmute yourself. Anyone just unmute. Shubham. Vaishnavi, Shubham, Omkar. Fine. So here you can see whatever be this white color rod you are looking here, that is nothing but what? That is a switch. Okay. So now I'll click on the start equipment, and now you will observe. You just keep your eye on these switches only, white switches. So that will goes to the ground. See, I have done ground switches on. Then I'll charge the capacitors in corner. You can see your capacitors is going to charge. Okay, now your capacitor, see, it is become green from the red. So now my charge capacitors has been charged, and now you can see here is the gap. So now I'm clicking to triggering generator. So generator is triggering now, and you can see this is a spare gap, and this is your all the capacitor discharged. And you can see how this current is rising to this. See at what particular moment around 0.1 second it has reached to the 2.49 kilo ampere. Okay, so like that way. Again, if suppose we'll change some values, then you can see I'll change the voltage into the 75. Okay, and again I'll click on the 75. Okay, and again I'll click on the restart, then start experiment. Okay, you can save this graph by clicking on here only. Okay, start experiment. Again I'm going to click on ground switches on. I am going to charge the capacitor. Here my capacitor is charging, and you can see it become green from red. And I'll clicking on the trigger. You can see here these two balls are coming towards, and there is a spark. And now my capacitor is charged, and here you can see as I have increased my voltage in kV, whatever be the charging voltage I have increased, then my current suddenly increased. See, my current is again increased. That last time it was around 2.498. It is right now 4 kilo ampere. So it is very easier, practical, and I hope that ICG very clear to you all. So here all the instructions they have given, and there are quizzes on there. So you can click on the standard lightning impulse current generator. So I'm randomly clicking on anything. So here you can click on the 8/2. Then relations between the circuit parameters for producing overdamp, underdamp, oscillatory waves, series RLC. So you can just check whether R2/L is greater than 4/C. All the things you will just check. For producing large values of impulse current, a number of capacitors are charged. That should be a series or parallel or something else. So you click just on this any point. You can take whatever you have understood. So you can click on the parallel discharge, any random I'm clicking. Then here also randomly you click. Then here also randomly click. Whatever be the answers, you can check here, submit, and see all the answers are wrong. So now again you just take another test, and this case this time you just change your answers. Okay, and you will just come to know whatever be the right answer. So now here this answer will become right, that is 0.87. Then read it again, and you will get the answers. So here you can see whatever be the answers that we are trying to find out, that we will get here. Okay, so whatever be the large value impulse currents, that is capacitors are charged in a parallel, and that should be discharged in parallel also. So like that way you can go for the various test and such kind of things you can understand. Okay, so this is all about the ICG practical. Okay, so this is not for our syllabus, but I'm just taking that for your knowledge. Already we have done these functioning of voltage doubler. Then these are the under development. So this I will take, and again this also rectangular. So again this objective theory you understood. Now here I'll click on the simulator. Okay, so my simulator will be available. Fine. So now here again you can see all the values are given. So we will see rectangular pulse, how it is going to generate rectangular pulse. Okay. So now see again, here is a ground switches. You can see. So I'm clicking on the start. All other values are the default values. So here is a starting. After starting, I'll push that ground switch. So see my ground switch is open now, and click on the charge capacitor. You can see all these red will become a green. See, all the capacitors are become now green, and now you will see where is my triggering generator. So I'm clicking on the trigger generator, and my generator is triggered, and now you will see it has given a one voice that is has track, and you can see there is a rectangular pulse current generator. So there is a rectangular pulse generated, you can see on a graph. So this is a simple, I am just explaining you as a we have time, that is why. Then this I am taking you to the whatever critical flashover of spare gap. So whatever flashover that is occurring, that I am taking to you here. So here you can see in the figure, I think already we have seen that one. So let us see whatever the spare diameter, I am taking a 5 centimeter. Spare gap, I'll take a 0.5 centimeter. And the voltage stage, that is I am taking for first time, that is 490. Okay. And now clicking on the start experiment. So I'll click on the start, then I am triggering to generator. You can see here switch is open and this ball, and here it is created. See, that is my critical flashover. So here my flashover occurred, and then sudden goes to down. Now I'll again restart, clicking on restart. Okay. Again, you can change this value. Here I'll take a 10. Spare gap, again I'll take 1. It is I'm taking around 10. So now again clicking on the start, then I'm triggering generator. See, you can see generator triggered. Now it is coming near, and it has been a crash, and you can see all the values that are available. Okay, so with that help, you can understand whatever be the flashover that is occurring, that values will be changed. If suppose we'll change the diameter, if we change the spare gap, we change the voltage stage, then we will get the values for the separate flashovers. Okay, so this is all about the virtual lab, whatever we have experiments. And now let me stop the sharing, and if you have any questions, if you have any doubts, please let me know, else we will stop today here. Okay, any doubt? So till now we had gone through all our syllabus, and now our syllabus is ended. Okay, so all are requested that test number 5 I will update today. I will share today afternoon. Okay, then test on the 6th unit, that will also I will try to upload by today evening. So up to tomorrow morning you just give this test. Those who have missed the previous test, that is test 1, test 2, test 3, test 4, that all are requested. If you want your internal continuous assessment mark, then you just appear for the test and pass the test, otherwise you will not get the marks. Okay, so let me just take his attendance. Okay, fine, now you can leave the class. I'll just share all the whatever study materials and all the things that I will share very soon. Okay, so I'm closing the meeting.